Hello and welcome to another lesson on GCSE physics. Today's learning intention is to understand internal energy. Now for the do it now task, there are two substances on the board, A and B, and I'm showing you what the particles look like in those substances. I would like you to tell me please which one has the most potential energy and explain why. Pause the video, write down your answer and then press play to check your answers. So the correct answer is that it is actually substance B that has the most potential energy. That is because the particles are further apart. The further apart the particles are, the greater the potential energy is between them. The success criteria for today is to recall what internal energy is, to describe the difference between specific latent heat of vaporization and the specific latent heat of fusion, and to calculate the specific latent heat of fusion for various substances. So let's begin with some key definitions that we need to know word for word. The first one is for latent heat of fusion. The specific latent heat of fusion is the amount of energy needed to change the state of 1 kilogram of a substance from solid to liquid without changing its temperature. So in other words, the amount of energy needed to, say, change 1 kilogram of ice to water but keeping it at 0 degrees. Now, very similar definition is the specific latent heat of vaporization. Most of the wording is the same, but this time we're looking at going from a liquid to a gas. So we can say that the specific latent heat of vaporization is the amount of energy needed to change the state of 1 kilogram of a substance from a liquid to a gas, again without changing temperature. Now there is an equation for working out specific latent heat of fusion and specific latent heat of vaporization, and it's here on the board now. It's the amount of energy given to a substance is equal to its mass multiplied by its specific latent heat. So one more key definition. The internal energy of a substance is the energy stored by the particles of the substance, and it is the sum of the particles' kinetic and potential energies. Of course, potential energy we've looked at already is to do with how close the particles are to each other, and kinetic energy is to do with how fast the particles are moving. So here you can see a liquid turning into a gas. Okay, I would like you to say, please, what is the name of this process? What happens to the potential energy of the particles and what happens to the kinetic energy of the particles? Pause the video and give your answers in as much detail as possible, please. Okay, so for question number one, what is the name of the process? There's actually two answers you can give me. I was after evaporation, but I would have accepted boiling as well. Boiling would be if we were actually, the liquid was already at its boiling point and then it was turning into a gas. What happens to the potential energy of the particles? Well, the potential energy is going to increase because the particles are moving further apart from each other. And then in terms of the kinetic energy, the particles in a gas move faster than the particles in a liquid do, so we can say that the kinetic energy is increased because the particles are moving with a greater speed. Okay, another task for you to have a go at, please. What happens to the internal energy of water when its temperature gets increased? So you can see there we've got a beaker of water on top of a Bunsen burner. Tell us please what happens to the internal energy, give a reason for your answer, pause the video and then press play to check your work. So the short answer is that the internal energy will increase, but to expand on that, that is because the particles will have gained more kinetic energy and so will be moving faster. Okay, another task to have a go at. Water can exist in both the liquid and gaseous state at 100 degrees Celsius. Compare the amount of internal energy in steam and water at 100 degrees, giving a reason for your answer. Pause the video and then press play to check your answer. So, the internal energy of the steam is going to be a lot higher than the water at the same temperature. That is because the internal energy is made up of both potential energy and kinetic energy. They will have the same kinetic energy because they're at the same temperature, but because the steam is a gas, the particles in the steam are further apart and so will have more potential energy. Okay, some questions for you to have a go at now, folks. Obviously, you can pause the video when the questions are on the screen if you've not got access to the worksheet, and then press play to check your answers. Question 1. Use words from the box below to complete the passage. You can only use a word once and you do not need to use all of the words. So when a system is heated, the internal energy of the system is going to increase. This either increases the temperature of the system or it causes a change of state. During a change of state, the temperature and the mass of the substance remain constant. A change of state is a physical change and it wants us to name these changes of state. So a gas to a liquid, that would be condensation, and then a liquid to gas would be evaporation. I will accept boiling for that answer though. And then what is meant by the term physical change, that's something that we looked at in a previous lesson. That is one where when the change is reversed, the material will recover its original properties. Question number 3. Heating an object increases its internal energy. What is meant by the term internal energy? So internal energy is the energy stored by the particles, and that includes both the potential energy and the kinetic energy. So the way you should give that definition in an exam is to say that internal energy is the total sum of the kinetic and potential energy of all the particles in a substance. 3.2. Heating an object can increase its temperature. State 2 things that the increase in a system's temperature depends on. So it would depend on the mass of the system, because obviously if there's more mass, it's going to need more energy to heat up. But it will also depend on the specific heat capacity of the material. Oil, for example, has a much lower heat capacity than water does. Question number 4. A student fills a test tube with 30 grams of water. He heats the water so that it begins to boil and collects all of the water vapour produced via a tube placed into the bung of the test tube. After the beaker has cooled, he finds that the mass of the water in the beaker is now 20 grams. State the mass of water vapour that the student collected. Explain your answer. So, if he's got 20 grams left and he started with 30 grams, because mass has to be conserved, that must mean that he's collected 10 grams of water vapour. Okay, then the explanation is that when a substance changes state, its mass doesn't change, or you could word that is that mass is conserved. Okay, second set of questions. Number 1, an immersion heater is used to boil 0.50 kilograms of water in a sealed container. Define the term specific latent heat. Note for this question that it hasn't specified latent heat of fusion or vaporization, so we shouldn't be specific about which change of state is happening. So we just say it's the amount of energy needed to change the state of 1 kilogram of a material with no change in temperature. 1.2. The lid is removed when the water begins to boil. The immersion heater transfers 1.13 megajoules, that capital M stands for megajoules, of energy to evaporate all the water. Calculate the specific latent heat of vaporization using an equation from the equations list. Well, it's an equation that we've learnt already today. It's energy is mass times specific latent heat. We are working out, though, the specific latent heat, so this equation needs to be written in the form of specific latent heat equals. The easiest way of rearranging an equation like that is to draw a triangle, and when we draw the triangle we would have energy on the top and then mass and specific latent heat on the bottom. From this we can see that energy is on top of mass, so we will be doing energy divided by mass to work out the specific latent heat. So the answer would actually come out as being 2.26 megajoules per kilogram. Question 2. Figure 1 shows a graph of temperature against time as a substance is heated. Describe what is happening between 3 and 8 minutes. So between 3 and 8 minutes we can see that the temperature isn't changing. That means that a change of state is going to be happening. Now because there's 2 changes of state that happen here, we can see there's 2 flat sections. The first one must be as we go from being a solid to a liquid. So that means that we are going to be melting. 2.2. Explain in terms of particles why the graph is flat between 3 to 8 minutes even though the substance is being heated. It's worth 3 marks. Definitely get into your answer the idea that a change of state is happening and that temperature remains constant during the change of state. The reason that that is the case is that energy is being used to break the bonds between the particles, so there is no increase in the substance's temperature, and the internal energy is being increased. We then look at the graph to work out the melting and boiling point of each substance. The melting point is -7 and the boiling point is 58 degrees.